Wednesday, 2nd of July, 1998. Today I read that 4 solar trucks got spilled and stopped 4 water purification centers in Kafr al-Sheikh. Reading the newspaper only gets more overwhelming and devastating day by day. But will it ever stop? Fast forward to today, Egypt's water problem is still relevant, but the Nation Builders program has reunited these 5 teenagers today to look for a solution and contribute to their country's progress in securing clean water for every Egyptian citizen. Using organic mantis shrimp shells to purify water, these high schoolers have the full potential to revolutionize water scarcity in Egypt.
We all deserve to live in a world where everyone has access to clean water and sanitation, and our freshwater ecosystems are safeguarded for the future. Water is our most precious resource. However, 1.8 billion people consume contaminated water resources, and about 2.4 billion people doesn't have access to simple hygiene facilities like bathroom and showers. By the year 2030, the UN wants to have access for clean, reliable, and affordable water for the whole world. And here, our role as Team E comes. Our challenge is SDG number 6, and we're planning to make something that most people say it's damaging for the Nile, to make it easy for us to purify water and make it safe and accessible to all.
In a world with an exponential growing population and demand for water resources, poorer communities can find it almost impossible to access water resources that are not contaminated. Even countries with sufficient water resources can find the threat of water scarcity. It can be caused as a result of many reasons, including the increasing of demand of water in a world with finite supply. Not only is the life above the land impacted by harm of water pollution, but aquatic organisms' life have been in danger up till now. Petroleum, chemical waste, and poisonous substances are leaked out onto water, causing death of many organisms and polluting the water that is absolutely used in cultivation, leading to unproductive soil, and all of that ends up with poverty and famine all over the world.
Hydrolobster solution and the prototype. As my teammate Mariam said, our main goal in Hydrolobster project is to turn the danger into an innovative clean water resource rather than the Nile River in Egypt. So first, what is the danger? First, we have Squala impusa or mantis shrimp, or in Egypt it's called the lyre shrimp. It has a negative impact on both the human health as well as the environment. So let's first emphasize its impact on the ecological balance. It is an invasive species that disrupts the Nile River ecosystem balance by eating large vegetation amounts. Furthermore, it causes an erosion in the sediments of the Nile. On the other hand, it has a negative impact on human health, where according to an article published by Dr. Maha Ghanem, professor of toxicology, School of Medicine, Alexandria University, that it has a long-term effect on human health by increasing the number of poisonous cases in Egypt, despite the warnings of the Egyptian Ministry of Public Health every year. The second danger is industrial wastewater, whose value hasn't been appreciated until recently, and it is increasingly recognized as a potential new source of clean water. So what are our water purifying steps in hydrolobster project? First, we have coagulation process. It will be done by aluminum sulfate. Aluminum sulfate. Its main aim in the project is to reduce water TSS or water total suspended solids, as well as adjusting water turbidity. The second process is using Squala imbusa shells, and maybe the question now is why? Because it contains a natural water purifying chemical called chitosan with a percentage of nearly 63% of its entire structure. So it shows great abilities in reducing heavy metals concentration and thus water TDS or water total dissolved solids. The third process is filtration accompanied by activated carbon. Its main aim is to reduce the remaining TDS as well as eliminating bad color. The activated carbon will eliminate the bad odors. The last step is UV disinfection lamp type C. Its main aim is to eliminate any biological microorganism as well as any organic contaminants by breaking down DNA structure and CC bonds respectively. So here is a prototype. As you could all see, here in this beaker where the coagulation process will take place, we will stir for nearly 7 minutes. After that, we will open the valve such that water will pass through this tube into the glass tube where the biological process takes place. Here is where the filtration will occur with the help of cotton, sand, and gravel as well as activated carbon. And here is the UV type C one. So the results we get was with the help of SRC, a City of Scientific Research and Technological Application in Alexandria. We get that TDS removal efficiency was of 82.12% and COD was nearly negligible. Here in this table, we can get that the origin of TDS was 2950 ppm or parts per million, and here after the two main treatment process it reached 527 ppm or parts per million. Here is the pH table. It was an origin of 8.3, and after the two main treatment process it reached 7.3, our ideal pH goal. So what about the water treatment cost per liter? It costs only 1 Egyptian pound, or in other words 0.033 American dollar, based on 10th February 2023 economic information.
Many things that need to be done in order to protect our environment. One highly important method for maintaining the health in the environment is to reduce water pollution, for which there are many effective solutions that can assist with this goal. The impact of our solution has many impacts on all aspects of life. First of all, it prevents many health issues. Second, it raises sanitation standard and enhances reliable water. And last thing, it boosts agriculture and food production. Our solution also helps to save other SDG, like good health and well-being. Health effects of consuming water with diseases causing microbes. Most life-threatening waterborne diseases caused by microbes such as typhoid fever or cholera. The more common illnesses caused by virus, bacteria, parasites can result in stomach pain, vomiting, diarrhea, headache, and fever and kidney failure. So our solution will prevent all of that. There is a range of water treatment sensors that can be used to be certain that the contaminants are being properly removed from water before the water is released back to environment. These sensors include pH sensor, conductivity sensors, and oxidation reduction potential.
By comparing, Squilla empusa shells or the lead shrimp shells contain tritosone with a percentage of 63 to 68%, while shrimp shells, another prior solution introduced, contain only 15%. Electrodialysis was also another prior solution introduced with an efficiency of just 74.5%. In other words, our project is more efficient by 7.64%. Now, on applying it to a large scale, the solar desalination process can be added to the project in Egypt, a region in Aswan Governorate called Benben, which receives the most solar energy in the entire world, using reflection mirrors to concentrate the sun rays on the contaminated water containers in order to be converted into pure freshwater vapor with no energy fees on the country whatsoever. Then, condensing it, it can yield high efficiency of the introduced water quality and its treatment cost. The project can also be applicable on a large scale in every factory, especially iron and steel industry ones, to recycle their wastewater instead of throwing it. This will save money for the factory, keep the environment safe, as well as stop depleting our limited freshwater resources.